Hello, everyone. Let's take a look at our bell ringer. Arrange the following metric prefixes in order from smallest to largest. From smallest to largest. Milli, deca, deci, and micro. Take a minute, pause the video, write everything down, and then come back and check in with me. Okay, I hope that this is just what your list looks like. Micro, milli, deci, deca. Micro means 1 millionth. Milli means 1,000th. Deci means 1/10th. And deca means 10. Don't forget to be reviewing your flashcards. Right, today we're going to be talking about energy changes in chemical reactions. And our learning objectives are, I can explain what the term endothermic means with regards to chemical reactions. And I can explain what the term exothermic means with regards to chemical reactions. So we've talked about kind of making chemical bonds and changing chemical bonds in chemical reactions. But what actually happens when we do that, when we break a chemical bond and then make another chemical bond with those different elements that we're working with? Well, we have chemical energy. So if you think back a couple of units now to when we talked about different types of energy, and we talk about chemical energy. Chemical energy is actually stored in the bonds of molecules. So in a chemical reaction, what we are actually doing anytime we have a chemical reaction is breaking and making chemical bonds. And that means that we're either going to be releasing or absorbing chemical energy. If you look at the bottom left side of the screen, bonds, when we break bonds, anytime we break bonds, that requires energy. We have to add energy. That can be thermal energy. Energy is heat, energy is all sorts of different things, but we need to add energy in order to break the bonds because the molecules are happier and more stable when they are bonded. Then, when we form bonds, we release energy. So when we have our individual atoms and they're all floating around and then they bump into each other, when they form those bonds, when they become bonded to one another, they release energy. We're going to talk about the two different types of reactions with regards to their energy requirements. And the first of those is endothermic. So thermic, hopefully you're saying, I know that means dealing with temperature. And endo means within. So that means that endothermic reactions are chemical reactions that absorb energy. They take that energy within. And so when we look at an overall, not a formal chemical equation like we did last week, we're going to keep working with those, so don't forget about those. But if you were to look at a very general equation of how an endothermic reaction happens, we would have our reactants plus thermal energy yields our products. In an endothermic reaction, the energy needed to break the bonds in the reactants is greater than the energy released when the product is formed. If we look at the graph I've got on the left side of the screen, which is the reaction progress versus energy, we can see that our reactants, A and B, A plus B, have a lower energy than our products, product C. And so over time, as that reaction is occurring, we're adding energy, we're increasing the energy in the system to get to our products, C. So we have an overall input. We're adding thermal energy to our system in order for the reaction to occur. And if you look at the picture right above the word endothermic, right up there, this is a great reminder of the fact that an endothermic reaction is going to make everything around it cold because it's going to take that thermal energy. all the thermal energy in the system or around the system is going to take the thermal energy into the system from its surroundings. So an endothermic reaction is a chemical reaction that absorbs energy. Now let's talk about exothermic reactions. Exo, hopefully you're saying, is outside or other. So it's the chemical reaction that releases energy. The energy, the thermal energy, is outside of the system. So in this case, if we look up on the upper left side of the screen where it says reactants yields products plus thermal energy, that means that when our reaction happens, the energy released when the bonds form in the products is greater than the energy needed to break the bonds in the reactants. So we're going to have thermal energy be a product. And exothermic reactions, if you look at the picture right above, make everything else warmer around them because they release energy from the system to its surroundings. And again, if we take a peek at that energy graph, we're looking at, remember, energy and reaction progress. So as time is going by, as that reaction is going on and happening, the energy of our products is lower than the energy of our reactants. So we start here with our reactants A plus B, and sometimes we might need a little bit more energy to get started. But then overall, as we drop in energy to get to our products, that heat, that thermal energy is going to be released. It's going to be given off, and we're going to end up with our products and thermal energy. And that's what an exothermic reaction is, a chemical reaction that releases energy.